Hello, my name is Jongun Park and let me start my project proposal. My project proposal is about semi-supervised active learning with mixed quality dataset. I will first introduce 4 different papers related to my project and then give project proposal. I selected these 4 works. First one is called MDN for short, which was on ICRA 2018. And the next one is called DDU for short. And these first 2 papers is about how to estimate uncertainty in deterministic neural networks. And the third one is about integration of semi-supervised learning framework and active learning framework presented in ICCV this year. And the last one is about uncertainty-aware pseudo-labeling on semi-supervised learning framework. The first paper is called Uncertainty-Aware Learning from Demonstration Using Mixture Density Networks with Sampling-Free Variance Modeling. The first paper proposed the way to estimate both epistemic and aleatoric uncertainty through mixture of density networks. Epistemic uncertainty can be viewed as disagreement between mixture predictions, and aleatoric uncertainty can be seen as average predicted variance of the Gaussian model. And the equation is seen in first, second, and third line. The paper uses negative log likelihood loss with mixture weights. And the next paper is deterministic neural networks with inductive biases capture epistemic and aleatoric uncertainty. It mainly targets on classification tasks, and they propose that epistemic uncertainty can be captured by feature density and aleatoric uncertainty can be captured by softmax entropy. They also proposed the dirty MNIST dataset, which is defined as sum of clean set and ambiguous set. Ambiguous MNIST dataset contains corrupted MNIST instances, and each instance in this set has multiple possible labels, and this is the reason why it is called ambiguous. The paper also contains active learning experiments on dirty MNIST. The paper reports that even when the data set contains only small number of clean sets and large number of ambiguous sets, epistemic uncertainties can still select clean informative data. In this slide, I will give more details and intuition about epistemic uncertainty proposed in this paper. The paper first followed the definition that epistemic uncertainty must decrease when the unseen data is added to training set. And this is the intuition why one can use distance or density in feature space as epistemic uncertainty. However, feature collapse can be the reason why this method fails to catch out of distribution instances. To prevent this, they use spectral normalization with residual connection to satisfy bi-Lipschitz constraint. The lower bound and upper bound represent sensitivity and smoothness respectively. To see more details about the spectral normalization with residual connection, you can see the paper called SNGP from this link. And the third paper is about semi-supervised active learning with temporal output disparity. This paper is about how to use active learning framework with semi-supervised learning framework. They use a cyclic output discrepancy as Curry method, and the equation is on the third line, and this represents difference between 2 predictions. First prediction is from the model weight that has been trained on previous active learning cycle, and the second prediction is from the current one. Besides this Curry method, they propose semi-supervised learning method to boost up speed of active learning. With baseline model denoted as omega bar and task model denoted as omega, they use prediction differences between these two as unlabeled pool loss. The baseline model is applied exponential moving average for each step with task model, and the overall loss becomes the sum of labeled loss and unlabeled loss multiplied with hyperparameter lambda. And the last paper is about uncertainty-aware pseudo-labeling for semi-supervised learning. For previous previous pseudo-labeling method, it was based on confidence scores, but due to poor calibration problem, it reduces its accuracy. The pseudo-label is defined in this first line, and this pseudo-label can be either multi-label or negative label. For the previous method, they use selection vector G as and it is only based on confidence scores, and it is on the last second line. And the first term denotes positive label, and the latter term denotes the negative label. To this end, they use uncertainty measure to deal with poor calibration problem. They modified the selection vector G with uncertainty. The first term denotes certain with high confidence score, which will give positive label, and the latter term denotes certain with low confidence, and which will give negative label. The binary cross entropy loss used in this pseudo label is defined on last second line. From these four papers, I propose semi-supervised active learning with mixed quality dataset. The objective of this project are twofold. First, to carry only clean informative data on active learning framework, and use semi-supervised learning method to boost up active learning. I am planning to evaluate on two mixed quality datasets. First one is dirty MNIST from DDU as introduced, and R3 dataset from this paper. R3 dataset contains both normal expert driving data and negative aggressive driving data. First of all, I propose to use mixture model, but also use feature space density as a query function. The proposed query function is on yellow box, which aims to gain instances with low electric uncertainty but has high epistemic uncertainty. Furthermore, I added feature space density to penalize the samples from being too far from learned sample. This is to prevent the querying near OD samples, which may not be informative. To boost up active learning framework, I also propose to use unlabeled set with semi-supervised method. I selected pseudo-labeling method, and the proposed loss function is written on the below part of the slide. For classification tasks like dirty MNIST, I just used the same loss function as on the last paper, and for the regression task, I made pseudo-label based on largest mixture rate and used loss attenuation for negative loss likelihood. And this is end of my proposal, and thank you for listening.